So as you come in, you can see it's a big open room. There's a small classroom section where we do lab briefings where the chairs are, and we can make sure people know the details of what they need to do in lab that week. For the first 3 weeks, we have students work on a computer with a very simple DAC in one person. It's not a group, it's individual work. And what we do with that is we get them to not be scared of the software for 3 weeks, right? We teach it to them. One of my favorite sayings is slow is smooth, smooth is fast. If I slow down and teach people, they'll understand it. If they understand it, they'll be able to do it when it gets harder. And so we do that for 3 weeks. And then we actually come in and we use this pressure transducer calibration system. So this is a more industrial quality data acquisition system. We use LabVIEW. LabVIEW is the software, National Instruments is the hardware, and we can calibrate pressure transducers. We'll do a couple of labs with that, including something called a state machine, where the mode of the program changes states as you run it. It's a very simple concept. It sounds a little scary, and hopefully by the time we're done with the lab, everyone agrees it's pretty straightforward. From there, we'll do a number of heat transfer experiments with thermocouples. We have an apparatus over in the edge here, a thermocouple welder. So we're able to take this thermocouple wire and a electrode, and there's a capacitor that actually discharges that causes it to fuse the tip of the wire. A thermocouple is a bimetallic junction, two different metals, and it generates a very small voltage that's dependent on temperature. Students learn how to weld those in this lab, and then we'll do several experiments with temperature measurement. Again, they start off fairly simple. Compare the measurement with a dial thermometer with what's called a cold junction reference. There's some equations that work and some physics that apply. And the reality is, when you use most industrial equipment, that's all baked in behind the scenes. But if you don't understand what's baked behind it, you can easily make gross errors. And so we help them avoid that. And then they do some experiments that use the internal adjustment. Eventually, we do an experiment where they take a metal sphere and they'll dip it in hot water, get it hot, and they'll dip it in cold water, and they'll look at the response curve, the thermal decay. It's a technique called lump capacitance. They do that in a heat transfer course. They learn it. In here, they learn it, but they see it. But by the time they get to heat transfer, they have an idea. This is a simple apparatus with a spring and a damper. It works very much like the shocks or struts on your car, so it's very practical. And they learned that the equation that governs the lump capacitance heat transfer with the thermos bottles and that governs the spring beam, they're apparently very different physical phenomenon, but the first order linear differential equation that governs it's the same. And so we really highlight the beauty of consistency in design and the way God has made things work. There's some simple models that explain apparently unrelated mechanisms that have a common creator. Eventually, students learn how to attach a strain gauge. So this is the first place they do it. They do it in lab 2, but they will do it in this measurements and instrumentation lab. This strain gauge foil gets glued onto the beam. It's a rather intricate, detailed process that if someone does it for you, it's easy. If you have to do it, it's impossible. And so we want our students to have hands-on skills and to really honor the technicians that they work with. And so one of the ways we honor our technician is our faculty. We know in principle how to do this, but our technician's really, really good at it. So we let him teach the students how to do it. He's got lots of hands-on capability. And so he teaches them how to do that. You could use this on a pressure vessel or a wing on a plane. How much strain, how much is it deflecting? It's a very practical technique. And then they'll end up deflecting on an apparatus. They'll be able to set the deflection and measure the strain. Another piece of equipment is the mechanical testing instrument. Force versus distance. Students do a lab with this where they can characterize brittle metals, ductile metals, and polymer. and they can find the elastic modules hands-on throughout, hands out from the start. Very practical, relevant education. We have students work in groups of 3, and the reasoning after the first few labs that we want them to work separately to learn how to write the report is that once they get through that, they can work in groups of 3. They write reports better. It's easier to depend on each other. And then they learn how to communicate and collaborate with others. In principle, we all know it. In practice, it's always a challenge. And so we make them work on it in this course. We got more stuff to show you. We really appreciate you taking time to view this. And if you get a chance to come to campus, I'd love to meet you, look you in the eye, shake your hand, hear what the Lord's doing in your life.